Good evening, everybody. Welcome to the February edition of the Triangle SQL Server Users Group Data Science Edition. Sorry for the late start, had a little bit of a delay on our side, but we are good to go now. So before I hand off to our speaker, I want to talk a little bit about SQL Saturday Raleigh. SQL Saturday Raleigh is coming up on Saturday, April 18th. It will be at Wake Tech RTP. Registration is free. Lunch is $15. It's optional. If you are so inclined, we are still accepting the possibility of speaking at SQL Saturday Raleigh. So our call for papers is still open until the end of the month. Then we're going to select speakers, we'll publish the schedule, and have full court press on getting people to show up for the event on, once again, April 18th. Also, Analytics Forward is coming up. Do you want to do the announcement for that, Rick?
Sure, real quick, I posted in the meetup. I'm on the board of Research Triangle Analysts. Analytics Forward is our annual event. This is the 6th annual event. It's an unconference, so anyone can pitch a talk. You could summarize a talk maybe that you have heard Kevin give and give a fresh perspective on the ideas. Hopefully Kevin will pitch a talk there. I know he has in the past. March 14th, it's going to be at NC State, SAS Hall. Keynote speaker is going to be Dr. Robert Earhart, and he's speaking on the hard data of climate science, which represents, I think, one of the most critical issues of our lifetimes, depending on what you believe. And so I think we're going to have a very healthy conversation, and please look on the meetup page for a link to that event. Thanks, Kevin.
Sure. Now, let's get to our main event. So here we go. I am now showing Hiram Fleitas, and I'm going to hand it straight off to Hiram so that he can take it away from here.
Well, thank you, everyone. I really appreciate you giving me the opportunity to share this material with the user group. This is intended to be a candid, casual presentation. Some of this material, it might not be necessarily new to you, but if it is, I hope that all of the content that I'm going to share with you, that you feel comfortable reproducing these demos and that you're confident in trying some of this technology out yourself. Like the abstract says, I have a lot of content to get through, but we do have ample time. We want you to ask as many questions as you may have. Kevin, if you could help me hear out some of those questions in case that I'm not able to hear them out very well because of the connection. But feel free to pause me at any time and tell me, Hiram, we have a question, and we can go over it.
Will do.
As you're seeing here on the screen, this is all my contact information, some recent certifications. I do work for an insurance company. They're based here out of Fort Lauderdale, and most of our customers are in the state of Florida. So I embarked on this project that I'm going to share with you guys and everyone, because ultimately some of the predictions that we were trying to do from a data science perspective was in essence to prevent churn. But the underlying problem, really what it boiled down to was, is the customer happy? And sentiment prediction was the feature inside of the database engine that allowed me to generate in real time AI analytics and bringing those features into transactional data without having to move our data into external systems. So let's look at, this is some information that you'll see in the PowerPoint around the company. Definitely the company has grown tremendously since I joined them over 2 years ago. But what we're going to cover are in essence these 5 demos, like how to set up this feature, how to debug it in case you're writing a Python application. We'll look at some comparison information. We'll talk about the Cognitive API, because in essence is what I'm leveraging for generating sentiment analysis predictions. We'll look at the new feature inside of the database engine as far as Spark, in case you want to stream incoming data, whether from IoT implementation or from online social media feedback into your database and generate predictions in the engine itself. So the presentation itself is tailored around the template that PASS offers for the summit. And this material was what I presented at the summit earlier in November of 2019. So I apologize again if you're seeing some things that you've already seen before. And if you want me to fast forward, we can get a little bit more deeper into some of these topics here. So all of the demos are scripted into the presentation itself, so nothing's going to go wrong here. And the beauty about that is that when you download the PowerPoint, you'll download all of the scripts and all of the demos and the result that you're expected to receive along with the PowerPoint itself. So the first thing that we're going to do is add the ML features to the engine. So for example, let's say since I think it was 2016 where Microsoft brought R into in database, and then 2017 we had the option to add Python as well, and now in 2019 we even have Java. So we're going to add those ML features, those machine learning features inside of the database engine. If you don't have 2016 or later, this is not a feature that you can add. But if you're uncomfortable with the upgrade process, I can tell you that of in-place instances from lower than 2016 into 2019 in a single shot. I don't recommend you doing that in production, but it is doable if you want to POC some of the stuff. And again, if there are some questions around how to do some of these things based on your specific use case, you can feel free to follow up with me and send me an email. We're more than happy to help you out. So we'll grant access for the services that are required to configure for them to run and install some pre-trained models in this first demo. So pre-trained models, what I mean by that is Microsoft actually ships with the product a separate cab that it'll download to SQL Server, the open source models that you can use, for example, image processing and text analytics. So I'll show you how to install those as well. So what am I talking about when I say sentiment analysis? I'm talking about something like this. If you were to go to the website right now for cognitive services for Azure, they let you actually copy paste verbiage in there and click on analyze. I wish I would show you the picture based on the text, but it does identify named entities. In essence, this is what we're going to be trying to reproduce. This text that you're seeing here is a quote from a TV show that I like to watch. It's called Trollhunters. In any case, this is a famous quote in the TV show. If you are a fan of Trollhunters, I hope there are some fans in the room. If not, it's okay. Maybe you'll watch the show. I do watch a lot of cartoons because I got 2 young kids, so we watch a lot of cartoons at home. Anyways, it's a pretty cool show. And this statement, the API is resulting with a 78% sentiment. That means that if you were to think about the sentiment ranking from 0 as being very negative and 100% being very positive, like happy and sad. In this case, it's 78% happy. That's what it's telling us. Was there a question?
None so far.
Okay. All right. That I heard someone speaking, so then I want to make sure I got a chance to hear them out. And so this is what we're going to be trying to reproduce inside of SQL Server, inside of the database engine. I'm going to give it a string like this, and I'm expecting this 78% result to come back. So when I talk about adding the features, I hope everyone in the room has installed SQL Server at one point or another. If you haven't, I can walk you end to end, but the key point of that step when you're going through the GUI in Windows, you'll get to the screen where you're selecting the features, and you have this option that says Machine Learning Services and Language Extension. In this case, I am going to select R and Python. Based on your requirement, you may only need to only check Python or only check R. All of the demos that I'm going to be showing, they are in Python, so I do recommend that you check both. But if you don't need R installed, you don't have to. In some cases, you may find some data science projects within your team that you don't want to come back to the screen and later install the language extension for R. You can just do both while you're adding this feature. In 2017, the UI looks exactly the same. You just don't have Java. In 2016, it is a little bit different. It actually says in database. So it's the same setting, but you're not going to have Python. You want to do this 2017 as well and onwards. So that's as far as adding the feature. And what this is going to do is Microsoft has actually done a great job at decoupling this new feature of machine learning from your transactional database processing. And what I mean by that is the SQL Server process itself is going to call a series of other executables that come with these features and DLLs to handle the communication for your machine learning services. So in case that there's ever an exploit, or let's just say hypothetically a virus or a bug in the DLL or a memory exploit, it'll only affect the isolated process where that exploit occurred, not your actual OLTP workload. Or perhaps, I mean, in the other case, it could be vice versa, right? So let's hope that realistically, some of the examples that we're going to go through is SQL Server calling the Launchpad executable, and that's going to call a Python launcher the DLL, and we'll come back and write the data back to SQL. If you were to have an external, let's say you worked on a Python project, and you're going to generate from Python itself an ODBC connection, the flow will be like the one here in the bottom, where it's a client Python application connecting to SQL versus SQL initiating the Python application, like the architecture on the top illustrates. And there's some references here where you can learn more about these slides. So when you add this feature in 2019, you're going to get this new user group inside of the server where SQL is installed. In this case, in 2017, it was a little bit different. I'm just making you aware because in 2017, you were getting a series of users as well. Now in 2019, those users are virtualized application containers. So there were folks that had some regulation compliance where they couldn't even add the feature to their farm because the number of security objects that it was creating on the Windows server. And that is no longer the case in 2019. As you can see, the members of that group is only the Launchpad service, which is the default. You can change that to be whatever domain service account, as well as if you're doing this on your laptop, like in my case I am, I added my own account to be a member of that group. So, well, the reason why I'm highlighting this group is that this is the group that the Launchpad service for our Python application is gonna run as. Another thing that I want you to take note here as far as configuration goes for this feature, in 2019, they also implemented more security features where by default, it blocks any Python application that you execute from SQL Server's runtime to connect externally to the internet. In this case, I'm just doing this on my laptop, I'm going to disable those outbound rules on my laptop so that my Python application can communicate outbound to the internet. And I'll talk a little bit about that why when I get into leveraging the Cognitive API. So just for you to be aware, because when the 2019 engine went GA, this is one of the topics that actually broke my demo, but it wasn't, they weren't blocked by default when we were going through the early adopters program and testing out the previous CTPs. So in any case, Windows Firewall, you need obviously local administrator, outbound rules, you disable these temporarily, but you normally want to create a rule where you're connecting to the Azure stack and public IPs to do this correctly. If you have any questions around that, feel free to reach out to me. So then we're going to configure for the instance, change the configuration of the instance to enable external scripts. It's pretty straightforward. I'm going to apply that right away, so I'm just going to run reconfigure with override. And what you're seeing here is T-SQL. I know it's a screenshot, but it's T-SQL instead of Azure Data Studio. That's why it's dark. I've received comments about my code being in dark, but it's become a disability of how long I've been doing this, and I can no longer author T-SQL in white screens instead of SSMS, so I even changed that to dark mode. So I apologize about that, but I made the font large enough so I hope everyone can see it. And so after Kevin I think that was Kevin laughing. So yeah, my eyes kind of hurt. So reconfigure with override. Well, then I have a dynamic SQL here that basically just checks, and you cannot do this if you're executing this command in Linux. The server name in Linux comes back different, but I'm just granting that new user group, that local user group, to the instance so that it can at least connect. I'm not granting it as a or even as a user inside of the database itself for my data sets. This command right here is only going to grant it access to just connect. Then after that, it's a matter of just, I'm going to restart the service because sometimes we configure with the override, this setting doesn't actually take effect. I still restart the SQL service and the Launchpad service so that it can understand that now it has permissions and this account can authenticate to the instance. Just some guidance here because I've been doing this for quite a while. Always install the latest CU. There were bug fixes as far as the path. When SQL was trying to call the runtime, that it was too long, and there were, I think it was CU3 in 2017 that fixed that. But always apply the latest CU if you're POCing this, reboot your machine after you add the feature as well, so there's not like a reboot pending. If you don't have CU3 or you can't install it and you're still dealing with 2017 with a prior CU, you can use this fixed path.cmd that basically just repoints inside of the Python launcher configuration to a shortcut so that you don't get a series of errors because the path is too long. You can execute that. That's inside of the code repo that I'll reference at the end of the presentation here, where you have access to all of the scripts. I also run the install ML models, which is a PowerShell script, and I pass in the default instance name. And I'll show you an example of that here on the next screen. So install ML models, this is the pre-trained models that Microsoft ships that you are actually going to download separately. Why do you download this separately and it doesn't come with the MSI? Well, Microsoft wanted to make specifically the Linux image that you use for Docker as small as possible. I think I've heard some people that in some cases, the first time they download it is 50 gigs. So imagine having to ship these pre-trained models along with that image. It just makes the download process a lot lengthier. So it's a separate cab file that you can use. This is a PowerShell script that's documented by Microsoft. I didn't write this PowerShell script. I've helped fix it so that it would support things such as CTPs that were landing and 2019 versions when it was still being called vNext or areas initially. In any case, the one that's publicly accessible now on the Docs Online, it works. The PowerShell script works perfectly. You don't have to change anything in it. You just give it the instance name. You run it inside of PowerShell as administrator. What you're going to take note here is the version that it references, because we'll use that in the second command that we're going to issue here. So, like I mentioned, this is going to download a cab file from Microsoft's repository, and that cab file has the .ml files that SQL is going to run from this location to do native predictions. So in this separate command here, this one is rsetup.exe, and you're going to use these parameters with the version that the Python script gave us, so that we, basically get the latest version of the cab. Now, the cab itself may have a series of bug fixes, but I've noticed, I've been using this for quite a while, these models are not changing. Like, they're not shipping an updated version of the model. Specifically, the one that we're going to use is this one right here called pre-trained that model. And when I talked about the size of this download, it's around 800 megs. So you're going to download the cab, and then it's going to decompress, and then you're going to have these files. These files in your file system are going to, it may add up to approximately 600 megabytes. So that's part of the reason why the team didn't, ship it with the MSI itself, so that the distribution will be as quickly as possible, as small as they could. If you weren't looking to add these features, then you wouldn't need the pre-trained models themselves. So ResNet, AlexNet, you could use ImageNet as well. You could use for other data science projects natively inside of the engine. So after that, let's say, day one, baby steps, data science, you want to create a store procedure that calls a simple Python application to generate a prediction. So this store procedure here is actually from one of Nelly's blog post, that basically it's going to evaluate a string. Let's say the input parameter here is text. that's nvarchar max. It's going to take that text, that input parameter, and it's going to evaluate if it's greater than 0.6, is going to result as positive, else as negative. So that's a pretty hard setting there. We're not actually getting an actual prediction, but we're going baby steps here. Any questions so far here? Are we good? Okay. Okay, all right, so pretty straightforward. And after I create that store procedure, I'm gonna call it 6 times here. So the reason why I'm showing you this is that I'm getting into the performance section of why I'm gonna do something beyond this. So 6 executions, because the topic here is, can we do this in real time, right? So 6 executions, it took 30 seconds, and I got, pretty decent predictions here. The score itself, whether it's negative or possible. So in this case, my code from the TV show Destiny, it came back as 0.5. And because I have that rule that if it's not greater than 0.6, it make it negative. So 0.5 typically means that the model had no idea what to do with it. So 0.5 is quite common because it's kind of like saying, I have no clue whether this is positive or negative, so I'm just going to give you a neutral ranking. What we're going to try to do here now is solve that problem. How can we get that 78% that we were talking about? And by the way, this decimal here, if you're basically converted to a percentage, we'll be talking about 31%, the sentiment score, 96%, the sentiment score, 46%, and so on. So we're going to try to fix this now. And I think that we can go obviously a lot faster than 6 predictions in 30 seconds. By the way, Microsoft has a demo on how to do this where they go, I believe, 1 million predictions per second. Now they have a lot beefier machines than my laptop. So I'm just doing this on my laptop. So demo 2. Let's talk a little bit about security, the requirements.txt, what are some common vulnerabilities that MITRE lists out for us so that we can secure our projects. And how to profile a Python application in case you're ever interested in debugging it or seeing why it's taking long. If you're traditionally a C# developer or a .NET developer, you probably are familiar with going in Visual Studio and running the debugger, and it'll step through the call stack. Well, you could do that with a Python application just as well. And the great thing about Python is it is clear text code, so you can modify it right there. There's nothing compiled, but there's a caveat around that because it's not compiled code. It's not going to perform obviously as fast as in-memory DLLs. So here I'm actually configuring inside of Visual Studio. I just created a blank solution that has a Python project, and I pointed the Python project to the SQL Server's environment. After I did that, and what I mean by pointing it to the runtime itself, I just gave it the prefix path and I gave it this name. It has no clue what to name it. It'll name it Python services. But what I'm pointing to here is basically the folder that after I added the feature to the engine, basically the folder where the environment inside of the engine, the runtime lives. So the reason why I'm doing that is because I want to generate part of my data science project, a requirements.txt, so that I can commit these requirements so that I have the same version of whatever Microsoft real-time prediction libraries are using documented with my project itself, or anything else as far as the version of pandas that I'm using, the version of PIP that I'm using, so on and so on. So we generate this requirement, and just fast forwarding here, I'm committed into Git source control, and GitHub is sending me now emails. Hey, Hiram, your supersonic project on Trollhunter data science sentiment prediction. Guess what? It's got some potential security vulnerabilities because we parsed your requirements.txt, and we found that version of pandas or pillow or whatever, whether you're using that library or not, we found that MITRE has announced a high severity exploit on it. So this is kind of like a good practice. Met folks and from different data science background, where they write a Jupyter notebook and they execute that notebook in whatever environment. They're not interested in managing the requirements. But this is something that perhaps when you're working through these projects, if you have folks inside of your IT umbrella that are interested in helping you out with this project and being as secure as possible, this is something that you can bring to the table on top of not just the real-time predictions that you're generating. Because these libraries, they will get installed on whatever machine you're going to generate your predictions from that are going to execute your Python application. So if you ever have to address some of those alerts, like let's say you got to take it any of these libraries, whether you're using it or not in your Python application to a newer version, you could do that right from Visual Studio by pointing to that environment and clicking to upgrade it, or you could just do it from a administrator command prompt window or from PowerShell and just execute the Python.exe inside of that runtime, inside of that directory with the module PIP to install, and then -u is to upgrade the package name. You could take it to whatever version number you want, like 0.16. That's what I mean here by x.y.c. And then if you want to return an output of those requirements or whatever libraries are installed, you could also do a PIP list, and it'll list out for you the libraries that are there. This will, like I mentioned, it will require administrative privileges. So when you do it through Visual Studio, it prompts you for elevated permissions. You could click on continue, elevate now, and so on. So not to be too much into this project, but there are some pretty severe out there. Like you can read some of these here, how this one has a SQL injection exploit in the order by parameter. And MITRE does a great job at keeping up with these. So I recommend that. So let's talk about profiling your Python application. Like now you're running it, your Python project is awesome, but let's say it's taken a minute to come back with the output and you expect that to come back in less than a minute. So you could click on Analyze from Visual Studio and launch the Python profile, and it'll give you the same cost stack like you're probably used to doing in .NET for VB or C#. And you can drill down through that cost stack and evaluate, what's causing that elapsed time to be so high. Like in this case, I actually drill down to it and I find that something inside of Pandas. Now, I'm not courageous enough to go ahead and change it myself, but at least I'm informed about why it takes a certain number of times. So I may, in this case, because I noticed that it was Pandas, I decided to build the data frame with a smaller data set. So like that, it wasn't taking too long to process too many rows in a single shot. So, and there's also an approach to do this with R. And all of the code that I'm showing you, you can reproduce it 100% in R as well. It's not verbatim, the syntax, but obviously what I mean is you can generate the predictions that I'm going to get here. And this is the example of me stepping through the cost stack inside of Pandas, and it talks to the another function here where it's calling a callback bridge, and so on. You could keep going here, and here is calling RealScalePy, which is native to Microsoft's distribution, and when it gets to RX serialized, you could see the exact line that's consuming the bulk of the work, the bulk of the time. So pretty cool stuff there in Visual Studio on how you could profile your Python application. I think I've met folks that for example, have used Spider, and I wasn't able to profile my app through Spider. I think the other one's called PyCharm. I've met folks that use PyCharm a lot too, and they didn't have that functionality before. They weren't sure how to go about it. So I've used Visual Studio for that, and it's helped. So let's talk about the third demo now. Basically, in database ML, because what I was doing before is that I was exchanging via a store procedure some string that I passed it as a parameter, and that store procedure sent it to the satellite service, and then Python itself generated the prediction, and then from Python, I sent the result back to SQL. But I want to avoid all of that exchange so I can go down from 30 seconds into something faster so I can do more than 6 rows. So we're going to talk about this feature or this parameter called real-time scoring only. And we're going to set that to true, which is the trick. Then we'll talk about SPRX predict, which is native assembly that you actually, it's .NET written for you to process models that you've trained locally, and they're serialized inside of your database as real-time scoring set to true. And you can use SPRX predict instead of the database to generate predictions with those models, and get something like as far as like to do whether it be logistic regression or decision trees. But if your data set is around sentiment analysis, you can get a close enough score. What we're trying to do here, by the way, if you ever think about it from a data science perspective, I'm not trying to get 100% accurate. I'm not trying to beat the API either. I'm trying to get a native prediction as quickly as possible. And if it's as close as I can get it to, great. If it's not, then I'll retrain the model, or I create another model based on a, we can talk about maybe perhaps like partitioning data sets and things like that. Like one data set may be around just troll hunter data, another can be around another Netflix TV show. And then I have different models for different Netflix TV shows so that they don't get corrupted in between with different data. And we'll look at the performance metrics behind this. Are we good so far? Any questions? Okay, so no questions?
No questions.
Okay, all right, perfect. So the next thing we're gonna do here is pretty straightforward. I'm going to create a table so I can write my model to that table. And what I mean by write the model to the table is I'm actually going to generate a binary and write that binary to the table as if it was a regular row. So that table here is going to be called models. This is the specific column that's going to hold the model itself. And then I just have description and when I created it, what language, whether I did it in Python or in R, the name, if I want to give it a name for the model, standard table. So then typical data science stuff, we're going to create a data set for training so that we could train our model with that view. And then we're going to create another view for testing our model. So the difference between these two views here is one, the training, I'm processing 90% of my data set. And the test one, I'm processing 10% of my data set here. This sample data set is actually in the worldwide importers database that Microsoft ships as a sample. And it's, again, from Nelly's blog post that I have a link here. If you want to download it, you can just download. This is a direct link to that database file, and you can restore it. I think you can restore it in 2016 and above. So the data is there. The table is called product reviews. So what she's doing here is she's taking actually product reviews. Think of this like if you had a bookstore and you had reviews on books, obviously, if you have a bookstore. But the actual table has reviews on other things besides books. I think it has got reviews on all sorts of products. All right, so we're going to create a store procedure here, similar like we did before, with a Python script inside of that store procedure. Here we're saying that the language of that script is Python. And then we're going to select from our training data set. It's pretty standard stuff. Going to basically step over the rows inside of the models table in case it already exists, just to delete from that table in case I run this on occasion, sometimes multiple times. So I replace the model. But what this code is doing here, this body of work, is in essence creating a two-part n-gram. And this is the key thing here, but we'll get into something better after this one. And then this is gonna weight that n-gram as far as like the first word independent in itself, and then the second word, and then the inverse of the second word in front of the first word and independent as well. So that n-gram, think of it kind of similar to an array, but and from a developer perspective, I can't remember how to describe it right now. But it's going to create an n-gram based on however long our input string may be. So we're going to execute that store procedure, and then we'll look at the contents of the models table. When I run this on my laptop, this is what my CPU does. The CPU on my laptop goes through the roof, the fan starts spinning, and I'm waiting there for a few minutes. I'm not going to ask you to wait for a few minutes, but it took, let's say on my laptop, it took 1.5 minutes to serialize this model to basically generate this binary and write it to SQL. So that is in 2017. When we look at 2019, it took 1 minute only. So we got a performance gain there between the two editions, and the same binary got read into the table. The code worked the same out of the box. It just ran faster in 2019. So just be aware that if you're ever training your model in production using this method, you might want to train that model and not crush the CPU during your high peak hours, right? Or maybe you want to train it somewhere else and then just generate an insert statement with that blob, with that binary, and just insert to whatever instance where you're distributing your model across perhaps a farm of multiple SQL servers. So you train it on one machine and you can just insert into others. Like you don't have to generate that on each individual machines. So now we're going to use that model to basically generate predictions. So this is a similar body of code that's in Python. The pound here is just so you could comment in Python out. And in some cases where I was troubleshooting, I needed to actually print the results in Python itself. So you could copy this and run it in Visual Studio outside of T-SQL. So like that, you can be sure that your Python application in itself runs successfully and you're not having like a syntax issue. Sometimes that's a little bit difficult for you to do when you're executing it within a store procedure. So in this case, we're going to select from our test view, and that should return the result for us, which is our prediction. So here, we're going to, the features that we installed, it allowed us to use Microsoft ML's library, the new library, Microsoft ML, that got installed with a feature. And inside of Microsoft ML, we're going to use RX Predict. And inside of RebuildScalePy, that also got installed, we're going to use RX Dataset. So these are the libraries that I'm using here. In this case, I'm using Pickle to I don't remember, I think it was to serialize the output, but let's keep going here because there's something better after this. So these are the product reviews. These are the predictions that I generated. Pretty cool stuff. But in this case, it only took 17 seconds to do almost 9,000 rows. So it's a lot faster than 6 rows in 30 seconds. So we're getting close here. And again, this is in my laptop. Any questions so far? Is everyone still awake?
Awake so far.
Okay, all right, good. Are we handing out Pepsis there, or? Well, I drink a lot of Pepsi here at home. Sometimes it helps me keep going. But in 2019 here, I ran the same body of code and it came back in just 10 seconds versus in 2017, it was coming back in 17 seconds. And again, this is like for like, I'm doing the exact same workload on my laptop. It's not like I had one machine with 2019 and another VM in 2017 with the same specs. No, I'm using the same workstation. So some performance gains there that I want to share with you. The reason why I showed you how to profile is because if you ever look at the execution plan of your store procedure, it'll look something like this, where it reaches the UDX operator and it says, oh, the cost of that thing was actually 0%. Well, guess what? That UDX is actually when the SQL executable calls the satellite service, where the satellite service has to run your Python application. And that's actually where the bulk of the time is what you're waiting on. So you can see that UDX operator says external script. So unfortunately, right now, it doesn't tell you any cost because it cannot predict any cost for it. It basically sends that external script to the satellite service, and the satellite service says, oh, this is a Python script, and I need to go do whatever it tells me to do. And then the satellite service takes however long as it needs. So that's the execution plan there. So how do we do real time, right? Like, I think we can go faster than 9,017 seconds or in 10 seconds. Like, I want to get as close to 1 million per second like Microsoft can. So why not? Let's, push this laptop to the limit. So what I'm going to do here is, because I'm not savvy enough to handle the chunks on my Python application of the exchange of the data set, I'm just going to say, hey, you know what? Go serial. Do one single thread. And one single thread means is that, like, say, Python, tell the CPU that you need one thread and you're going to work over that chunk of the data. And when that thread is done, then send me the output of that chunk, and then go request another thread with another chunk of data. So you could actually parallel multiple chunks and you can manage multiple threads. My recommendation here is, if you do not use this, you may get a out of memory exception, where what happens is that the chunk itself exceeds the amount of memory that single thread can finish in time. So your Python application will actually return a memory exception error. So to avoid that, I'm just going to go single threaded right now because my laptop is not that fancy. But if you feel comfortable, you want to do 2 instead of 1, you can give that a shot. And then from there, you could take it to 3 until you maybe run out of memory, or decide how to manage your chunks a little bit more intelligently. But this RX logistic regression is very well documented on Microsoft's website, and they do explain how to manage the chunks a little bit more intelligently. In my case, I gave it a shot. I wasn't very successful at it. So, sometimes you got to make things happen before 5 p.m. And this is how I made it happen.
Is there any way to zoom just a little bit?
Yeah, I should. Yeah, there you go. So you could see there, train threads is set to 1. And in the other section where I'm using RX serialized model, I'm telling RX serialized model the parameter real-time scoring only is set that to true. So what that's going to allow me to do is that when the binary gets created, it's going to let me use that binary with SPRX predict, so that I can generate real-time predictions. So let me zoom back out here. That's okay. And again, this code is in the presentation when you download it. Notice that I've commented out pickle. So in this case, pickle is not going to generate binary for me. I'm going to use instead the library RX serialized model, which is Microsoft's version that got installed with the features that I added, and I'll explain why. So when I execute this store procedure to train my new real-time model on my workstation, I think it was my workstation at home or the workstation in the office, it took about 1 minute and 14 seconds. And on my laptop, it took about 2 minutes and 40 seconds. It's the same laptop that I'm using right now. This is what it did to the CPU on my laptop. You could see the threads here spinning up, spinning down, processing the chunks, and spinning. When it finished training the model, all of that went idle because obviously Hiram is just running Outlook and Chrome. This is the output. You see, it took 2 minutes and 40 seconds on the laptop, and in 2019 it took 1 minute only. So we got some performance gain there I was pretty happy about. And the data set that I'm training it over is exactly the same database, exactly the same number of rows, and it ran faster. So now we're ready to, well, before I get to that, because I want to say we're ready to try SPRX predict, but what I want you to take away from here is that this new model that I created with, and let me back up for a second here, with RX serialized, which this command here, RX serialized model, instead of pickle, notice how I commented out pickle dumps. It's commented out on the Python script. This new model is a lot smaller. it's only 6 megabytes versus 55 megabytes. So if you're trying to get into real time, the smaller the model, the faster you're going to be able to load it into memory. So, and it has nothing to do with the volume of the data set. In this case, my volume of the data set is like for like. It's the same number of rows. I've trained it over the same 90%. So 6 megabytes, or it's always going to perform faster than 55 megabytes. So now let's try SPRX Predict. To turn SPRX Predict on, you show advanced options, you set that to 1, run reconfigure. You have to enable CLR in your instance. If you don't have it turned on, I gotta tell you, I use CLR for a lot of stuff, such as regex, parsing email addresses, things around that nature, and it's faster. It's great. Compile code is great. So we turn CLR on, and then this is not best practice, by the way. You don't want to set the database always, I'm just doing this on my laptop, to trustworthy on. What you want to do is there's another setting where you flag the assembly itself as safe. And when you say trustworthy equals on, it means that any assembly inside of that database can do whatever it wants to the machine. So I don't recommend doing that. In this case, I'm just doing it on my laptop for demo purposes, so I'm just going to do that. But otherwise, you'll be changing the security of the new assemblies that get deployed individually. And it's a multitude of them. I'll list them up for you. I'm also changing the database owner here to SA. Otherwise, I can use, for example, the service account. The reason why I'm doing that is because I don't want the assembly to be logging into the machine as the DBA that restored the database, which in this case is myself because it's my laptop. But I wanted to use the service account that the service is running as. So I changed the database owner because it's set to trustworthy equals on. So then we're going to enable real-time predictions. You could do this to the instance first. With this command, register rext.exe. We're going to install the runtimes for the entire SQL Server instance, but we're going to scope it to enable the assemblies. We're going to deploy them on individual databases. So if you're a multi-tenant environment where you have a database for customer A that you cannot do things because customer B doesn't, you have different regulations and so on, you can scope this to have those assemblies on a specific database. So let's say that you're doing some cross-database work and you want to generate your predictions in your, DBA database. So deploy these assemblies to your DBA database and generate the predictions there. Make the exchange of the cross-database pool of your strings, and you can output them to whatever application you want, or write them to the DBA database themselves. So the cool takeaway here is that you can scope these assemblies to individual databases, not to the entire instance. All right, so when we run that command here, I just run it directly from the environment itself, register rext install runtimes. It actually adds the assemblies to the instance, and then it says here command runtimes install succeeded. Then we target it to a specific database, and it creates these assemblies into the database. Now, something may happen here. Like, let's say that the assembly system that runtime serialization already existed because you restored this database from 2017, and now you're redeploying this stuff in a new environment that's 2019. Well, script out those assemblies. Perhaps you have one that's internal to your group, and the good thing that you script it out is because you're going to have to drop it and redeploy the new ones that are for 2019. You want to get the latest version, so like that you get the bug fixes and the performance enhancements. And then at the end, it's going to say command succeeded, and you'll see here creating store procedure. That store procedure depends on all of these assemblies. So you want to get this output here. All right. And after you script out any of those assemblies, you do have to go through a series of dropping them in order because one may depend on another one. So you drop them in order, you first script them out in order, you drop them in order. And if you have any that are custom, for example, like some custom SQL CLR utilities that you may have, you execute that through SSMS or Azure Data Studio, where you recompile the assembly afterwards. Something else that may happen there that I can share with you guys is the version of .NET. So for example, if you have, I first was doing this in Windows Server 2012, and the version of .NET was different. Then 2019, when I went GA, it required 2016. So then I had to recompile those assemblies because the version of .NET that was shipping with 2019 was different. So I had to go through actually dropping all of these, even though they already existed, from restoring the database from a 2019 environment, because the OS of that previous instance was actually Windows Server 2012. So just some caveats that I can share with you with going through the nuance of this project for quite some time. And the reason why I'm sharing them, full-heartedly with you is because the output that you'll get, they're not as informative as you wish that they were. All right, so now that we deployed our assemblies, let's get some predictions, right? We're gonna call SPRX predict by passing our real-time model into a variable, and we'll pass that model into SPRX predict with the input of our test view. And in this case, it comes back in 3 seconds, the same 9,000 rows. Now notice that I didn't get the string payload here, I only got the prediction. So you could say, Hiram, you cheated. Sure, but I'm gonna show you even a better method from here. So 9,000 rows, I couldn't do the million because it's on my laptop in 3 seconds. This is just a performance metric. Again, this is on my laptop, as SPRX predict did run 5 times faster. So, depends on you how deep you want to go into this sort of project. A lot of folks, they stop right here. They write a Python application, they generate predictions, however long it takes, they got the predictions that they ended up needing. Some other folks take it a step further and they do it in database. And then some other folks take it even a step further, where you probably seen examples from the .NET team where as you're typing, you're actually generating the prediction inside of your ASP.NET app or .NET Core project. So, compile code, sure. I've gotten feedback where, you cheated, it's a memory, it's compiled code, but, that's what I want. I want to go fast. I want to go real time. So how do I get there? And this is how you get there. Same volume of rows, how many rows I did per second, how long they took. So pretty simple stuff. And we'll get to some more demos, but maybe if you have any questions so far, I can help answer them. No questions. Okay.
Not a question.
Okay, go ahead.
Now, the answer might be no because of the thing that you're going to show later, but have you used the CLR version in a production environment?
You're referring to SPRX predict?
Yes.
Yes.
Okay.
Yes.
See, I haven't.
And
I've always used the thing you're going to show later, or like built-in R functionality. So it's interesting.
Yes. So No, it's a good question, Kevin, because the argument then becomes is like, okay, the other thing that I'm about to show here, how can we avoid the cost of sending that payload over the internet, and how do we do it locally, right? So I'll get to that in a second. It's a great question, but you can end up, like I mentioned in the beginning, I'm not trying to beat the API. I'm not trying to get to 100%. Predict the lottery numbers or anything around that nature. I'm trying to generate at least a prediction of which way is north. Like, are these people, is the sentiment at least going in the right direction? And then I can tune the model locally to generate real-time predictions using the CLR, like you pointed out. And if I get feedback from my users saying, hey, these predictions are out of whack, then I can go back to the API and be like, okay, how about, is it looking better now? And if they say yes, then I have to retrain my local model so that I can use SPRX predict, at least attempt to use SPRX predict again. And sometimes the performance with the API is satisfactory, so you can even stop there. But in order for you to do 1 million transactions per second, and you're hosted on-prem, or if you're running this on Azure Stack, you can use SPRX predict to help you get there. And sending the data or the payload every single time over the wire will add latency. Okay, so let's talk about how to send it over the wire, right? Like how to use the API, which is what I'm going to show you now. First thing is, if you haven't worked with JSON, JSON has been available in SQL Server, I believe, since 2016. In this case, we're going to use for JSON path so that we can build the JSON document in flight within the view that we have to use to communicate with the API. Based on that API response, we have to actually normalize the response, which is going to be a JSON response, and take the response and write it to a SQL table so that we can report on top of it. And you probably have seen, demos on how to do some of the sentiment analysis inside of Power BI. You're happy with that implementation, which is, I think it's great, but now you're boxed into just using it in Power BI. But if I want to display that prediction in real time inside of my native CRM that my team has built, what Microsoft answer is like, oh, well, now you could use embedded. And then, well, what if I haven't published this to the app service? I'm still kind of boxed into that. So doing this natively instead of your transactional processing system allows you to consume it from wherever you want. At that point, it's just data. I kind of got a warning here that my battery is low. So let me make sure. Oh, it says 25 minutes. I should find my charger and connect it. I'm kind of gonna, let me step through this demo and I'll run to find my charger because there's some examples here that I'm gonna skip. So the first step here, this is the Python application that I'm executing from Azure Data Studio. If you haven't built the cognitive service already, it's pretty simple. Just if you do a Google search or a Bing search for sentiment analysis on Azure, you'll get to a trial and you can set up a simple free subscription with an instance of the cognitive service for sentiment for text analytics. And it's not going to cost you anything. If you need help evaluating it, my key is right here. No, I'm kidding. This key, I already changed it. But if you need help trying it out and you are considering bringing some of this work into production, I'll be more than happy to help you out with that. All right, so this Python application is going to generate the JSON document that I need to write back to the database. In this case, it actually communicated to the API with my key, the sentiment module, and it gave me a response. So far, so good. So the demos themselves walk through this baby step method of, okay, how do I first do it in Python? And then, okay, how do I now send it more than one document? Because in this case, I just sent it one. Let's say I had to send 100 of them. And then how do I build an array of that? And then how do I generate that from SQL? So all of these demos walk through all of that. If you're not familiar with Azure Data Studio, you could switch the kernels here and you could test one thing versus another. You can, if you're using Azure Data Studio, you might as well create a notebook. And like that, it persists the output of the syntax above. And in a single notebook, you can have different body of work, whether it be T-SQL like this, or Python inside of the same notebook. So definitely check that out. And so these are other examples of sending multiple multiple documents, multiple strings, and getting a result for each, a prediction for each string. So far, so good. Now let's create our review. So this is, kind of like the important step here. So we're using, this is the same select that we're using before. I'm just hard coding the language here. So that I can generate that JSON document in the format that the API is expecting to receive it in. So I'm saying for JSON path, and the root of that JSON path is going to be called documents. And I create a kind of like if you think of it as a derived table here called documents, so that the header of that select statement actually says document at the top. And then I execute the external script so that I can test that I can create a data frame, because when you use SP execute external script, SQL is actually saying, hey, this Python application, that object, it's not a dictionary, or it's not, I can't remember the other type of object, but it's expecting it to be a data frame. And if you don't treat it as such, it will crash and you don't know why. So this is an example of how I test that to make sure that I can communicate back and forth with the Python application with the array that I'm going to have it connect. Now, in this case, so I'm again going baby steps back to Python using the ODBC method to write to the database itself instead of attempting it via SP execute external script. I still get the predictions from Python, and I get the response in JSON format. So far, so good. If you ever need to upgrade it before, like I pointed out, due to the MITRE vulnerabilities, you could use this inside of Azure Data Studio as well. That command there that I showed you. Let's say if you had to test serializing the result set, if you want to just try serializing the result set, because the API will, the response will come back as a dictionary, and then you got to convert it to a data frame. And you do that with Json Normalized. Here I'm assigning it to a variable called df, which I know it's going to be a data frame. But if you're not confident that it's a data frame and you just want to print the type of the class, you can use this here. You could say, hey, print the type of that variable, and it'll say, you know what, that variable is a data frame. So far, so good. Here I basically step over a table and I recreate the table. I can tell you that in production, I have this as a column store table, and I just write API results all day based on hundreds of reports that operations is executing. So I'm, in essence, logging my predictions so that later on, if I need to generate the prediction over the same data, I don't call the API, I can just pull it from a table. Or if I want to see how things are trending, I can just read it from a table instead of just regenerate predictions for the entire year's worth of work. All right, so this is going to be the store procedure that you kind of take home with you. So here it's going to be called get cognitive API. In this case, I use my own key. I call a string. This is the Python application. I normalize the response and I write it back to SQL here into this API results. Now, if you want to persist the data, don't step over it like I'm doing here. Just create the table once and you do an insert into over and over again. And you can have an if statement that if the ID of the rows that you passed already exists, like let's say you're talking about claim IDs. If there's already a prediction for that claim ID and the loss description hasn't changed, there's no reason for you to regenerate the sentiment behind the loss description. All right, so we talk more about Trollhunters, right? Because we were trying to solve that code that I got the performance problem fixed, but I haven't fixed the quality of data, what I call the quality of my predictions yet. So this is the entire dialogue of the Trollhunters episode where that code came, and that code is here. I don't remember in which line. I think it's Blinky, the one that tells Jim, which is our hero, the statement that I posted to the API before. But this table codes has hundreds of the entire episode dialogue, different characters speaking to each other. So I execute I'm testing here that I'm generating the document. Here you could see that this is the actual code for the glory of Merlin, Daylight, or something like that. No, that wasn't the actual code. But it's in that table, trust me, inside that table codes. My JSON document looks correct. So I'm getting confident that I could send it to the API and the API is not going to bark at me. This is the store procedure and the body of work to execute my store procedure. And then I'm going to read from the table codes. What I'm doing here is that I'm updating the code table and setting the result from the API response as the sentiment column for each statement or each quote. So in this case, some of them do come back as 5 because it's got no clue what to do with it. But the one that we were trying to get for 78%, it's here. It's here somewhere. I think it's further down. It's here further down in the screenshot, but trust me, I solved the data quality issue that I wanted to to solve. So now that I have that prediction, I could ask a little bit more meaningful questions like, hey, what is the average sentiment for my characters? And here I find that, I've seen the series multiple times, and turns out that Claire, in this particular dialogue or this episode, she was the most positive one that would speak the most positive, and the character that was the most negative. This might be like one of the evil characters. So I don't remember if it's like one of the sidekick heroes in the TV show. So now you're getting to, are my predictions meaningful, right? You're trying to perhaps develop a little bit more decision making behind the predictions that you were trying to produce. So back to your question, Kevin, as far as like, am I using the CLR? This attempt here, it's actually the code that I take the responses from the API and I train a model based on those responses, and I create that model that I train is set to real-time scoring, set to true, and here this is the stored procedure to train the model, get Trollhunter model. Here you can see I'm setting real-time only set to true. And I write to the models table the output of that. I have a small model here because there were only about 100 strings in that codes table. So then I take SPRX predict here. You can see I'm calling SPRX predict for that model. And I create a pivot of the output where the output itself depends on your data set, but it's predicting the similarity of the strings themselves to what it trained on. So in this case, if I sort the pivot, sorry, let me back up here. If I sort the pivot, it's saying that most of them, it has a confidence of 26% that they're 70% positive. Does that make sense? Because it didn't make sense to me. I spent about half a day at Summit meeting with the product team about this problem, and maybe like you found, Kevin, like it's not fully cooked yet. But I hope that the confusion here is how it falls off the scale, because then it says, all right, I'm 26% sure that there's 70%, that the sentiment score should be around 70%. But then I'm 21% sure that the sentiment score should be 1%. I mean, 10% here, not 1%. So that's the confusing aspect of this. So here, what SPRX predict is telling me is there's the similarity of the strings. And so when I tried to address this problem, it basically boiled down to I need to train it on more data. Like there's not enough data for me to make this determination, because I'd expect it to go from 70 to maybe 60, and then from 60 to keep falling down in order, like in 70, 60, 50, 40, 30, and so on. But it's not doing that. It's like a little bit all over the place here. Like it's going from 70 to 10 to 80, all the way back up to 90. So this eluded.
Uh-oh.
There was that battery.
So Hiram will be back as soon as he gets his battery. As he's doing that, the Bayesian in me says that apparently he needs a few thousand more simulations to get the results he wants. While he's grabbing his power charger and coming back online, let me promote SQL Saturday Raleigh once more.
Time for a commercial.
Yeah, exactly. Commercial break. So if there are any questions in chat, chop them in, and I can answer whatever I can. Otherwise, we'll wait until Hiram gets back and have him answer questions.
Can you talk about prior or just your general sense of whether data science presentations might appear in SQL Saturday or during SQL Saturday?
Okay, good question. Will there be data science presentations during SQL Saturday? The answer is probably yes.
Wait a minute, I asked you less than a month ago and you said probably not.
There's probably
You
in
need
front of
more
both of
training
us.
too.
So
Probably. Yes,
let's go to SQLSaturday.com and check out Raleigh, and let's figure out who has submitted so far.
I submitted one today.
Yeah, Mike did it today. I saw that came in. We can see all the submitted sessions so far. There are 49. To this point, Sorry?
You can't fit 49.
No, we're not going to have people submit more than one. It's fine. So as far as data science goes, since we are talking about the data science group, I definitely would appreciate anybody interested in doing a presentation on data science topics, because so far, here's Mike's using window functions. Window functions are great, by the way. But so far, it looks like there hasn't been too much in the sense of data science. Welcome back, Hiram. I was just vamping until you were able to get that charger.
Yes, ran and grabbed it from my backpack. The thing that I was hoping to be able to find wasn't much the charger, was an outlet here, because I got one hanging from the roof and the other one was somewhere along the wall. It's quite dark, so, but thankfully, other things have happened here that it was safe to get around. And so there's another demo here that's around, PDF. If you ever want to take the body, and I apologize if I'm jumping right back into the presentation. Is that okay?
Oh, absolutely.
Okay, all right. So another demo here that I was gonna go through is, like, let's say your data set wasn't Netflix TV shows and it was PDFs that you've transcribed. You could, just use the same schema and the same store procedure that I've created for you. Just copy paste my code and try it over your data. It's not going to send me an email with anything. I don't want to get any more emails. No, I'm kidding. So this fifth demo, I'm going to give you a little bit more insight. And the reason why I have this is, at Summit, we always want to show the latest and greatest. So I'm going to show you some performance metric here between the three versions of the engine, how I've operationalized this solution in production with regards to perhaps using this into even something like a paginated report. Like I talked about using it in Power BI, and I'm sure you've seen those sort of examples, but how you can just use it anywhere. I'll talk about terms and ethics here that I think it's important from a data science perspective for us. And this doesn't come up as much because we're all technologists and we just want to write code and make things work. But it's something to consider here. And I'll share with you guys the story behind that. And then we'll get into streaming with Spark. Like, Kevin is way more vast knowledgeable when it comes to that topic than I am, but I'll show you an example of it to give you an introduction. So when I'm talking about comparing performance between 2016, 17, and 19, I already gave you some performance metrics, but this is kind of like a sandbox that I have. It's not a VM in Azure. There's a VM on-prem where I run HammerDB to benchmark the engine itself, not the storage or the VM metrics. What I benchmark here is the instance, the version itself. So with HammerDB, if you haven't tried it out, it's a free app. You can download it. You can point it to SQL. You can also use it to benchmark Oracle or different type of workloads. But it generates a fictitious number of users and a fictitious workload, and it'll tell you the transactions per minute that you're getting. In this case, for 2016, you could see my VM it has 8 vCPUs, 72 gigs of RAM, same storage, and there may be people in the room that are great VMware administrators and they know how to do certain tunings. But in this case, I'm just running a basic benchmark test here. It has nothing. The point of this test is nothing to do with the metrics of my infrastructure. It's just that I can compare 2016 over the same infrastructure versus 2017 over exactly the same infrastructure. And another reason I'm showing you this is because, Microsoft has some really awesome demos where they spin up 200 VMs in a single shot and execute billions of transactions per second, or I don't remember what the latest number was in Bob's demos, but they're beautiful. I just don't have that sort of infrastructure. Or sometimes those demos, because they're trying to showcase something different. They're trying to showcase like how fast the new version goes, not necessarily this version versus the old version over the same hardware. And in my case, it's that demo. It's this version versus the old version over the same exact hardware. And so I got that result over the benchmark test using the same configuration, even less memory and less CPU over the same storage backend. I got this performance metric, transactions per minute, in 2017. So quite a win there. And then in 2019, same exact VM, same exact number of cores, and the same amount of RAM, I got even a little bit more of a performance gain. So, and I actually ran this test when I think I had this presentation at 8 a.m. in Seattle. So it was like 11 a.m. Eastern time, which is peak hour for my production infrastructure. And I expected to get lower results because our production environment was supposed to be busy, but I only ran this test for a few minutes so I can document it for the sake of the presentation at Summit. And it ran better, so I was quite surprised. So just sharing some of that with you. And when I talked about a paginated report, so let's say when you asked me, Kevin, earlier about did I use this in production, how did I operationalize this? It ended up being, as you think about it, you're like, okay, how is the user going to consume it? Where is the user going now to look at this data? It ended up that they had some sort of log, some sort of report that they hammer all day, and they're looking at things. And those things, that report is going to continue to get hammered no matter what feature you add to it, no matter what sort of intelligence or prediction you add to it. So I figured, you know what, let me try to just beta test something and experiment to see if they like this feature or not. So I just added a parameter to the report, the RDL itself, and I created I think this is I want to say conditional column, but I don't remember if it's a conditional column. In any case, there's a link here on how to do this. Basically, this column only exists, it only appears on the result grid when this parameter is set to yes. And in this case, I'm calling the exact same store procedure that my RDL always called for its own data set. I just had an if statement that when this parameter is set to yes, the store procedure says, hey, get sentiment equals 1 and enter the body of work where you got to call the Python logic to write to the API results table and then read from the API results table to return the sentiment. So I basically formatted in a native T-SQL for the output of the sentiment to be percentage. You can use format for that and say, P, and it'll come back as a percentage. You don't have to do that in the RDL itself. And then the ones that were 50% that I had no clue what to do with, I returned it as blank, not to confuse anyone, and I don't want anyone to generate an average or an average. So I just had an if statement over the column there that if it was 0.5, return null. I think the function that I use for that is if or something like that. In any case, I'm happy to share some of those functions with you if you need it. And this article here explains how to change the settings for the result grid inside of the RDL so that you have the column appear when the parameter is set to true or not only. So then this column doesn't appear ever if it's set to false. And 90% of the time, I actually left this column set to no by default. So someone explicitly has to know that this thing even exists and come in here and set it to yes, and that's going to generate traffic to call the API. So when I first operationalized this, I used the lowest cost tier of the API for the cognitive service. It was a matter of like maybe less than $5 a month because no one was coming even in here and sending it to yes. It was only Hiram sending it to yes to test. But then, I got a little bit more adoption, and the CEO of the company called me and he told me, you know what, this is great thinking. We can use this for a lot of different applications and improve our customer loyalty and improve the satisfaction that the quality of service that we provide from an insurance perspective to our customers. And so it was a great success story that what I'm trying to share with you guys here is that if you give this a shot, from a technical perspective, it's awesome. It's fun. But the moment that you get a win like that from your internal customers, you know, it makes the entire sacrifice and the evenings and the years that I put into this all well worth it. Because a lot of, you know, you get into a data science perspective, some folks might be like, I even got questions like, did you turn on the Terminator and the database server is running slow? What's going on? Did you turn on that AI? So, you know, those are different questions to address, but they're all great too. All right, so let's talk about the terms and ethics behind this. So when I first attempted this, I was consuming the Yelp API to get product reviews or Yelp reviews over a business. So let's say I'm the owner of a restaurant. Hypothetically, Hiram owns a restaurant and Hiram is the business owner of that restaurant. Hiram learns how to write T-SQL and he calls the Yelp API via Python. He passes his business key. Everything's authenticated. Everything's, you know, I've gone through all the songs and dance of setting up my Yelp app and my Yelp key, and I'm consuming content from the Yelp social media network now. And I'm taking my customer feedback from Yelp and I'm writing it to my SQL Server database, and I'm generating sentiment analysis using the predictions. And I was dealing with an issue that the product reviews, when I was calling the API, they were truncated. So you'd be surprised that people on Yelp, they write sermons or, you know, 6 paragraphs product reviews, which is okay, you know, that's valid. That's a solid review right there. So how do you generate sentiment prediction? Because Yelp doesn't do that for you. Yelp tells you, no, they wrote this sermon and they gave you 1 star. I'm like, so wait a minute, now I got to read this sermon to figure out what this 1 star means. So we call that tagged data. You have a string with a tag of 1, or maybe they give it 5 stars. So you have a string with a tag of 5. So you could do a data science project based on tag data. It's quite simple. You can do that to predict churn, predict costs, and things around that nature. But when it's on tag data, like the data set that I was dealing with, no one said this loss description was 1 star or 5 star. They just told me the hurricane blew down the fence. You know, and now, so things around that nature. The point that I'm trying to get at here is I reached out to their technical support team for the API project, and this is a response that I got from them. The response, it's pretty basically states you cannot do this for B2B sort of analysis. If you do it, it has to be customer facing. You have to show your consumers on your public website what you're doing with their data that they're posting on Yelp, and things around that nature. And this is quite a while ago. It may have changed since then. And I was persistent because I'm pretty stubborn, and I tried, and they told me, no, it's illegal. So you probably heard of another Netflix reference here. I think it's called The Great Hack, where the ethics behind this is, if your customers know that you're doing this analysis over the data, are they going to be biased in giving you honest reviews? Maybe, maybe not. So before you attempt something like this, what I'm trying to tell you is call your internal legal team in your company and ask them, hey, this is the project that I'm working on. Are we safe with the recording that they hear when they dial the 800 number? Is that, am I okay with doing this? Because you do not want to be the next Cambridge Analytica because you didn't go through the right steps here. All right, so I'm getting texted here from probably my wife. Yes. And yeah, so, you know, you host a WebEx and you don't tell your wife that you're going to be home late. So another low prediction there. let's talk about streaming, right? So if you're familiar with 2019, one of the new features that you get inside the big data cluster release is Spark. So Spark allows you to do this sort of project that I just did, but over petabytes of data. Like, let's say your data set is not one episode of a Netflix TV show of 10 characters speaking to each other. Let's say your data set is Walmart and product reviews over Facebook, Twitter, all in real time. So this is petabytes of data. So Spark lends itself very well to that memory computation to distribute your chunks without you having to force it to go serial like I had to do to spin up a single thread because I couldn't manage the chunks well enough. So let's say that you're getting, this is a body of work that's public. It's one of Microsoft's code samples. But what it's going to do is going to, and you have this notebook in the code repo that I'm going to reference to here in the end. But it's going to connect to Twitter based on a series of users or a hashtag, and it's going to capture those tweets. It's going to write those tweets to the HDFS data pool, and then you can take that and expose it as an external table. You don't even have to materialize it locally into SQL and bring all of that or index it. You can just leave it on the external table and use the same native predictions that I showed you, or use the same step to call the Cognitive API if you want to for those tweets, the actual text. And this sample will give you the entire payload of the text. Like, you will get the full tweet. And this is all legal. I didn't get banned from Twitter like I probably got from Yelp. So anyways, here I just do your T-SQL developers, they can run native T-SQL select statements from a table. It doesn't matter whether it's an external table or an internal table or not. And I can have a clause, I can have a like, and I can do an order on things such as the number of followers. So I know that whatever this person says, because they have a high number of followers, it may have a higher impact on my product or my business, whether negatively the sentiment may be or positively. So Spark lends itself very well to this, and this is why I wanted to show you. And Microsoft has an example of, you can use a service called, I think it's streams.io, where you have, think of it like a flow or kind of like an SSIS GUI, where you have containers and they're linked to different steps and different tasks. And those tasks can be custom Python scripts that call the API, or that download the tweets, or that write to the big data cluster, and have a multitude of steps. If you don't want to use a notebook like the one that I have here, it's the same body of work, but just in a single notebook. You can use a service like a SaaS offering like streams.io, and it'll connect directly to the big data cluster without a problem. All right, and then you can, if you're familiar with the Sandance visual inside of Azure Data Studio, you can visualize the data directly from Azure Data Studio without having to take it into something like Power BI. And you have, somewhat rich visualizations there, like I'm showing you here, a 3D chart. So in summary, I'm going to summarize everything I talked about. Added the features, the executional components. I showed you that architecture, how to configure the access, configure the external scripts, customize the working directory if you need the fix behind that, or if you haven't applied the right CU yet, how to install the pre-trained models, how to use rsetup.exe, using Visual Studio for your Python application, you writing it in SSMS if you want, or in Azure Data Studio, how to profile your Python application, the information that comes back in the execution plan, how your CPU on your machine may get impacted when you train a model, how to use real-time scoring and RX serialize, so that you serialize to your table a smaller binary versus with using Pickle, it's not going to compress as well. and then how to use SPRX-Predict, and how SPRX-Predict gave me the best performance in my example. Then I covered the API itself, different kernels that you can use inside of the Azure Data Studio notebook, for JSON path, which is what I use to build the documents to send to the Cognitive API, and the new feature inside of the Big Data Cluster for Spark. These are some references. This is the code repo that has all of the scripts, the full data set of this presentation. The PowerPoint is in PowerPoint and in PDF. This is a link that you definitely need for Trollhunters, so you can watch the series. And this is where you go watch the 7 series. I think it's 7 seasons or 3 seasons. I can't remember right now, but the ML services these are some simple tutorials, and I can tell you that like the very first thing I ever tried in this data science endeavor was this link, the AKA, and you cannot see it there because I'm hovering over it, and obviously the HTML string doesn't fit in this agenda window, in this resources window, but it's aka.ms/MSSQL dev. And I'll take you to that website because I think we got a few more moments here. So let's say day one, you're a hardcore T-SQL developer or .NET developer and you want to try something out. This is where the step 101 where I tell someone to go, whether you want to generate a project inside of R or in Python. And these data sets are over ski shop rentals or customer clustering, and how you can do them both in R and in Python. So I've met with a lot of like financial analysts that they're great R developers, and I show them these examples, and they're like, wait a minute, you're telling me I don't have to ask for a CSV from the SQL team and I can just do this locally there? And I'm like, yes. And life becomes great, and people are happy. So that's a great resource that I could share with you. If you're more advanced and you want to go deeper, this is another link. The workshop examples from Bob Ward and Anna, and there's another guy, I think it's Buck. Yeah. So they have a little bit more of a data science approach. My approach is a little bit more like, how do I make this work in production and apply it and see if the result that I'm getting is even of value. But there's a ton of content here that's free that you can step through, and it'll give you a great introduction into becoming a data scientist and leveraging SQL for that. Other great examples, if you haven't seen the JFK lab, the one for IoT devices, they're right here on this link that Microsoft has developed. And some of those examples can help you advocate some of this technology at your workplace. Perhaps some of your coworkers haven't seen it yet, and you can share with them. Samples for just R. There's a ton of material here. This is the same link that I was sharing before. It's just that the MSSQL Dev one takes you to just the predictive analytics one. This one actually takes you into creating even like a .NET app with or a Ruby app with a SQL backend storage engine. If you're interested in handling the threads a little bit more intelligent than I did, you can look at this link as well. And the PowerShell script to install the pre-trained models is here on this link. So yeah, this is my contact information. So thank you very much, everyone. I feel free to ask any questions, or if you want to shoot me an email later, or feel free to email me as well with them. So thank you again, Kevin, for giving me the opportunity to speak with the user group. This has been a pleasure.
Absolutely. Thank you, Hiram.
You're welcome.
Yeah.